in 5.6 you learn a technique called integration by parts. So we're going to talk about that briefly. We often just call it parts because, hey, we're integrating everything. It comes from the product rule, so if you think what's the derivative of u times v, where u and v are both functions, so they have derivatives that are non-zero, you're going to get u prime v plus u v prime, or as we'll often write it, du times v plus u times dv, where we're using this Leibniz abuse to write things nicer. If you rewrite that, getting rid of the derivative, that's the same as saying uv is equal to the integral of v du plus the integral of u dv. Again, it's just the product rule, but it looks kind of funny. We're going to start actually with problems that look like this right side, so let's separate it. That means that the integral of u dv is equal to the u times v that was already there, minus the other integral, the integral of v du. But that doesn't seem to help us much since we're saying start with an integral and finish with an integral. The whole idea is we're going to choose u's and v's that make our life easier in the long term. This new integral should be one we can solve. So let's start with an example. We're going to take the integral of x times sine x dx. Okay? In this problem we've got to pick a u, and we'll talk about its derivative, and we're going to pick a dv, and we'll talk about its integral. Now how do we choose it? That's the most important thing. When I start with a u, I take its derivative, so its derivative better get easier. And when I take dv, I need to be able to integrate it, and I need its integral to not get harder. So for example, if I was to choose x right here, then when I integrated it, I would get 1/2 x squared. Did that make our new integral easier or harder? It made it harder, so we'll cancel that out. So we're not going to do it that way. Instead, we're going to pick u to be x, and the derivative of x is just going to be 1 dx. That means everything else, sine of x dx, and its integral, negative cosine of x, will be dv and v. Now we're just filling in the blanks from the formula above. So we look back up there. The integral, this integral, the one in the box. So the integral of u dv is what we have. So the integral x sine of x dx will be equal to u, which we said was x, times v, which we said was negative cosine. I'll put my negative out front, minus the integral of v du. So we look at our v again, and that's negative cosine still, so I'll pull my negative out, or actually I'll leave it inside once and then I'll simplify it. Negative cosine of x, that's my v, and my du is just dx. So hopefully we've gone from something we can't integrate here to something we can integrate here. There's no more x in the way, so we can simply integrate cosine. So, final answer would be that x sine of x dx, when we integrate it, we get negative x times cosine of x. We said the negatives cancel here, so we have a positive, and when you integrate cosine, you get sine, so plus sine of x. Now when your last integral sign disappears, that's when we'll put our plus c. You could put one every time. That would be fine, but you'd have to keep track of them all. So this would be our final answer. This is a function whose derivative is x times sine of x when you simplify it. So there are two major things to watch for, is that there are two harder versions. So the two hard versions, they both have a trick to them. I'm not going to go through them. I'm going to point out which example in the book shows you how. One hard version is if you only see one function in the integral, for instance ln of x dx, or if you see the integral of arc sine of x dx. When I look at those, I don't think parts first, because there's only one function, and parts always has two functions, a u and a dv. So when I'm looking at these, I'm thinking I surely don't know that. The key here is that we know their derivatives, not their integrals. So this is like example 5 in the book, and the trick is to say set dv to be 1 dx. You just take that differential and call it its own function, which is entirely fine. The second hard trick is functions like e to the x times sine of x dx. If you look above, you saw that we chose u to be x in our first example so that its derivative got nicer. Because if u had been dv, its integral got worse. Well, if you take e to the x and sine x and you keep taking derivatives, they just repeat. The derivative of e to the x is e to the x, and its derivative is e to the x, and so on. The derivative of sine is cosine, then negative sine, then negative cosine, and on and on and on. So those won't ever become an easier function on the right. So you need to look at example 4 in your textbook to see how to handle that. I think of them as circular because they're just repeating, so I call them circular in class. That's our hint there, but the idea is you have two functions and they're just going to repeat over and over. They don't actually simplify. So I hope that helps you get started with the product rule. Have a great day.